Now, when we talked about complex fractions before, there was two methods to solving this. The first was we added or subtracted the numerator, added, subtracted the denominator, whichever one we were doing, to get a fraction on top, fraction on bottom. Then we divided and worked all the way through there. And for the most part, we saw that once and said, no, we're not going to do that again. That's a lot of work. So the other method was using the least common denominator. We need to find a term or set of terms that we can multiply through the numerator and denominator and simplify everything out. And so what we look at are the denominators in the numerator and denominator. So we're looking at the bottom of the fractions in the fraction. That's a lot of fractions. So we're looking at x squared and x. What do we need to multiply x squared by in the 1 over x squared to get it to simplify? Well, x squared, yes? Because x squared, if we multiply the top one by x squared, they would cancel out and we would be good. What would we need for the denominator? X. Would x squared also work for it? Is if we multiply the bottom one by x squared, we would get what? X squared over x, which is a single x. Is the denominator gone? Does x have a denominator? No. No, it works. Because it would be very tempting to want to say that we want to multiply everything by x squared and x. But because it's a single term, we don't need it. Because the top one needs 2, the bottom one needs 1, so the whole thing just needs 2. And I still feel like these here, when we have our monomials, these single terms, x squared and x, are sometimes harder to see what we need to multiply them by than if we just had sets of parentheses. So what we can do is multiply the whole thing by x squared over x squared. And when we do this, we're going to multiply each of the terms by the x squared. So the numerator, x squared times 1 is just x squared. Minus x squared times 1 over x squared would be x squared over x squared. The denominator, 1 times x squared would be x squared minus x squared over x. Questions on this so far? Now we do have some stuff that simplifies in the numerator. The x squared over x squared would simplify to 1. In the denominator we'd have x squared minus, well, x squared over x would simplify to just x. Now we need to make sure the numerator and denominator don't factor in any way, shape, or form. The denominator, x squared and x, do they have a greatest common factor? So they both have an x, yes? So we can factor it out. If I factor an x out of x squared, we're left with x minus 1. So we have x times x minus 1. Well, the numerator factor. So it doesn't have a greatest common factor for sure. Yes. Because is x squared a perfect square? X and x, yes? Is 1 a perfect square? What times itself is 1? Because 1 times 1 is, yeah. So we have a difference of perfect squares, x minus 1 and x plus 1. Will anything cancel? And x minus 1 leaving us with, and that's as simplified as it gets. Now, there are methods for us to split it up and simplify it further. That's really doing addition backwards, giving us x over x plus 1 over x, which would simplify to 1 plus 1 over x. But is this any simpler than that? No. And we're not working on partial fraction decomposition, so we're not going to do that. Questions on any of this here? So, let's look at the next one. because the only denominator we have is the one on top, because we're not thinking of 5 plus a as the denominator. It is 1, but we want to simplify the denominator and the numerator of this fraction. And to do that, we're going to multiply everything by a. In the numerator, a times 25 over a is really 25a over a, minus a times a is a squared. The denominator, a times 5 is 5a, plus a times a is a squared. Any questions on this so far? Now the numerator, 25a over a, will simplify to just 25. Really everything else stays the same. Now, numerator, denominator, looking at the denominator, can we factor 5a plus a squared? Because it has the greatest common factor of a. Now our first term would indeed be plus a. Now we could have rewritten that as a plus 5. Those would have been the same thing, but we'll see why I left it the other way. Now the numerator, 25 minus a squared. There's no greatest common factor, is there? Is it a difference of perfect squares? Because 25 is 5 and 5, a squared is a and a. So we would have two sets of parentheses. We would have plus and minus. What term or number would go first? It would be 5, because the 5 comes from 25. 25 was first, yes? So it would go first. Yes. Now, we're very used to having a squared first, x squared first, the variable squared first, minus the other, but it still works this way here. And here, these would 5 minus a over a. Questions on this here? Hopefully these are a lot easier than the last time we went over them. I think 2 more and then we should be good with these here. We'll do this one and the last one, and then we'll go from there. Looking at this one here, we do have 2 fractions inside of this fraction, yes? The denominator in the numerator is x plus 4. The denominator in the denominator is, so we will need to multiply top and bottom by x plus 4. How many times though? Because in each denominator, how many times does x plus 4 appear? Once, so we only need it once. The only reason we would need it more than that is if, say, the denominator had x plus 4 squared, then we would need it twice. But it does not have that, so we just need to multiply top and bottom by x plus 4. Because that's almost the same as the first one. The denominator for the bottom one had just x, the top one had x squared, so we needed 2 of them. And if we multiply the numerator by this, we'd have 3 times x plus 4 over x plus 4, minus 2 times x plus 4. We can do the same thing with the denominator. We'd have 5 times x plus 4, plus 2 times x plus 4 over x plus 4. Because again, when we multiply each of these terms, we're multiplying it with the tops of the fractions or just the number. On the numerator, 3 times x plus 4 over x plus 4 would cancel, leaving us with just 3. Now we can distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. In the denominator, we can distribute the 5. 5 times x is? 5 times 4 is plus 20. The x plus 4's cancel out, leaving us with plus 2. Combine like terms first. Yeah, then we would factor. So negative 2x, 3 minus 8 is negative 5. The denominator would be 5x plus 22. Now the question is there a greatest common factor between negative 2x and negative 5? Besides negative 1? No. How about 5x and 22? So that's it there. Questions on this here? How do we feel about these here? Yeah. Want to see one more? Definitely. Let's go on and start this one here. This one here shouldn't be too bad. Now looking at this one here, what do we need to multiply top and bottom by to get the fractions in the top and bottom to simplify? Yes. We need to multiply top and bottom by x plus 1 and x to get them all to simplify down. Because in the denominators, x only shows up once. We don't have an x squared, so we don't need x squared. And x plus 1 only shows up once in each denominator. Yes? Now, at this point here, I'm going to show you a little bit of a shortcut to make it easier. Because what we're doing is multiplying this first one by x times x plus 1, and this other numerator by x and x plus 1, yes? Well, I know that the x plus 1 and x plus 1 will. And what does that leave us with? X times x, which is x. The next one, we have x and x cancels, so we still have the minus. 1 times x plus 1. And when I do this here, I will multiply monomials, so the x and x, I will multiply those together. If we had 2 parentheses, I would just rewrite them, because that would be a lot to do in this first step. Yep. And we can do the same thing here. The x plus 1 and x plus 1 cancels, leaving us with x times x, which is just x squared, plus here the x and x would cancel, leaving us with 1 times x plus 1. Now we could have done this process like we just did here on the first ones. It's the same thing. But I wanted y'all to see how it simplified first before we got to this. Now the only thing we need to do next is to distribute this negative. So in the numerator we still have x squared, but the positive x is now negative. Our positive 1 is now negative 1. The denominator is just going to be x plus 1. And that is it. Yeah. Because whenever the first term is just x squared and the third term is 1, the only way that this will factor is either A, there is no middle term, difference of perfect squares, or B, the middle term is going to be positive or negative 2. The bottom one will not factor because it has imaginary solutions or imaginary factors. And the numerator would have irrational factors. So this is it here. Questions on any of this here? Do we feel good with these here? So we can do one more. Y'all want to look at this one here or this one here? This one. No, now this one here, it's very tempting to want to say that we want to multiply everything by 2x and x minus 4 and 2x squared minus 7x minus 4 because we have three different things. But the question is, will 2x squared minus 7x minus 4 factor? We know 2x plus 1 doesn't factor. 3x. X minus 4 is also in simplified form. Now, 2x squared minus 7x minus 4 does not have a greatest common factor. There's not something that goes into all three terms. But we can do our two sets of parentheses with three spaces. Since the 4 is negative, our signs are opposite, plus and minus. Now we need the factors of 2x squared. So x and x. 2x and x, and the 2 would be with the plus or with the minus? Plus. Now, it is kind of somewhat dealing with how we've gone through factoring and trying to work these out, how we get to this. But also, what would be nice to have one of these sets of parentheses be? 2x plus 1, because that would mean one less thing that we have to multiply everything by, yes? So I'm going to put it with the plus. All the factors of 4 are 1 and 4, 2 and 2. Now I'm going to put 2 and 2 down. For y'all, don't write that in, especially if you're writing with pen. Because the first one, 2x plus 2, does that have a greatest common factor? Yeah, it's 2. Does our polynomial that we're starting with have a greatest common factor? No. So if it doesn't have one, the sets of parentheses can't either. Which is part of the reason that we would have 1 and 4. Interestingly enough, x minus 4 also shows up, doesn't it? So that's going to make this a lot easier to work with. Because what are we going to need to multiply everything by? Yes. Yes. 2x plus 1 and x minus 4. Now, just like with the last one, we can do the same thing, because trying to multiply this all together and rewrite it as individual fractions would take up a lot of space. So we're going to multiply each and every single one of these by 2x plus 1 and x minus 4. Really? That's what we did with this here. Is we multiplied the entire numerator and denominator by it. And in the first one, 2x plus 1 and 2x plus 1 will cancel, leaving us with 3 times x minus 4. The middle one, the x minus 4 and x minus 4 will cancel, leaving us with negative 3x times 2x plus 1 minus, because both of these will cancel out. Now the denominator, x minus 4 and x minus 4 will cancel, leaving us with 3x plus 5 times 2x plus 1. Now, does anything cancel with the 2? No. But what would 2x plus 1 times x minus 4 turn into? 2x squared minus 7x minus 4? Because that's where we got it from. But if you didn't notice that, and we're going to go that route, we can still put 2x plus 1 times x minus 4 because nothing simplifies. And we can multiply through, we'll get back there. But any questions on how we got to this point here? We good with this so far? No? Confused where? Here? With the 2? Okay, so we're multiplying it by the denominators. So when we looked at this here, so 2x plus 1 does appear both of these spots once. So we need it once, we'll do top and bottom. Since we do also have x minus 4, which appears in each one of these once, we need it once. So that cleared that up? Yeah. Now, the only time we would need it more than once is if it appeared in one of the bottoms of the fraction. So here, 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 or here. Any of these more than once. Now, this part here, we're going to start distributing. So we're going to multiply through by 3. 3 times x is 3x. 3 times negative 4 is negative 12. Negative 3x times 2x is negative 6x squared. Negative 3 times 1 is going to be negative 3x minus 27x. Now in the denominators, we can distribute this out. 3x times 2x is 6x squared. 3x times 1 is going to be plus 3x. 5 times 2x is plus 10x. And 5 times 1 is plus 5. Now we don't need parentheses around these because there's not a number out front of these two here. So we can just drop the parentheses. But these two here do have that 2 out front, so we can put the 2, multiply, combine like terms, and then add it in. 2x times x is 2x squared. 2x times negative 4 is negative 8x. 1 times x is plus x, and 1 times negative 4 is negative 4. So even though this does, we'd multiply the whole thing by it. Yep, so both, yeah, so both of these would hit here and here. So you have it, but since this doesn't have a denominator, we use both. Does that make more sense? Yeah. It's kind of weird that, and that can sometimes throw you off when all of a sudden one of them has nothing that cancels, but the rest does. Now, at this point here, we can start simplifying some things. There we go. Now the numerator, we can go on and start combining like terms. Well, negative 6x squared does not have any like terms, so it's just negative 6x squared. However, 3x minus 3x is 0. They're gone. So all we have left is negative minus 12. Now the denominator does have these two like terms here, 3x and 10x. So we can combine those, gives us 13x plus 5. Now it seems like 5 and 2 would be like terms, but the 2 is actually multiplying all that there. So it's just plus 5. Now we do have like terms inside the parentheses. and we're going to combine those. So really what we're having to do is simplify the parentheses, then multiply it by 2, and then combine like terms. So it works out the denominator had a lot more steps to it to get it to simplified form. Is the numerator already as simplified as it gets? Yes. So let's go on and start factoring it as we're finishing up with the denominator. Is there a greatest common factor between negative 6x squared, negative 27, and negative 12? And I'd pull the negative out. Whenever x squared is negative, I try to take that negative out to make it positive. If we factor negative 3 out of negative 6, we get 2x squared. If we factor negative 3 out of negative 27, we get plus 9x. And if we factor a negative 3 out of 12, we get plus 4. Now at this point here, we can distribute the positive 2. 2 times 2x squared is 4x squared. 2 times negative 7x is negative 14x. And 2 times 4 is plus 8. I feel like I flipped a sign. I did. Because the 4 should have been negative, and this should have been negative. Sorry about that. Luckily, I've done this a time or two, so I knew that shouldn't have been right. Any questions on how we got to this here, besides that one sign change? Now, the numerator, we can go on and start factoring it. Since the 4 is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x, then we have 2 and 1. And the factors of 4 that we want are 1 and 4. Because unfortunately 2 and 2, no matter how we would set it up, would have given us a greatest common factor of 2 with our 2x. And those wouldn't have worked. Denominator 6x squared and 4x squared is 10x squared. Right. Okay. I'm assuming y'all have that as 6x squared, not x cubed, yes? Yeah. No, that's just a typo. Righto. Now, 13x minus 14x is, and 5 minus 8 is negative 3. We have 2 last steps. Because the denominator finally got to a point we can factor it. And what are we hoping one of the factors is? Exactly, 2x plus 1 or x plus 4. Since the 3 is negative, our signs are opposite, positive and negative. Factors of 10x squared are 1 and 10, 2 and 5. Well, where should we put the 2? Positive, because if we want one of them to either be 2x plus 1 or x plus 4, well, 2x plus 1 looks like the better choice. And the only factors of 3 are 1 and. And this is the setup we want to get something to be similar. And if we checked it to make sure, 2x times negative 3 is negative 6x. 1 times 5x is plus 5x, which does give us a negative x. But it also tells us that these two, telling us that we have negative 3 times x plus 4 over 5x minus 3. Questions on any of this here? Yep.